Welcome to the virtual seminar Technologies to Extend the Shelf Life of Mangoes. My name is Wanda Ramos, and I am a research specialist at the National Mango Board. I will be your moderator for today's session. To begin our discussion on technologies to extend the shelf life of mangoes, it is my pleasure to introduce today's speaker, Dr. Jeffrey Brecht. Dr. Jeffrey Brecht is a professor and post-harvest extension specialist in the Horticultural Sciences Department at the University of Florida. He teaches principles of post-harvest horticulture to undergraduate and graduate students. His primary research focuses on plant organ development and senescence and on evaluating technologies and practices within the distribution system to enhance fruit and vegetables quality. Dr. Brecht has led multiple research projects funded by the National Mango Board, including monitoring and evaluation of the mango supply chain to improve mango quality, fresh cut mangoes as a value added product, demonstrating the feasibility of modified atmosphere packaging, plus ethylene scrubbing for mangoes. Through this extension program, he demonstrates the impact of post-harvest procedures and technologies on maintaining product quality. He has participated in research development and training activities in over 20 countries and has authored more than 650 technical publications, including 250 peer-reviewed journal articles. Dr. Brecht was named a University of Florida Research Foundation professor in 2002 and was honored as a fellow of the American Society of Horticultural Science in 2006. Welcome, Dr. Jeffrey Brecht.
Thank you, Wanda. Hello, everyone. It's my pleasure to be here today and talk about the subject. As Wanda mentioned, I've done a lot of mango research funded by the National Mango Board. That first project on this supply chain, I think, was in 2007, 2009. So the Mango Board was relatively young at that time. We were maybe one of the first few projects that was funded by the National Mango Board with the box tax money from the industry. So I'm a post-harvest physiologist, and my specialty is actually how fresh fruits and vegetables are handled and how they behave in the distribution system. And so that's the way I'm going to approach this for mangoes as well. And the first point I want to make, I'm going to talk about technologies to extend shelf life, but the purpose of how we handle mangoes is not necessarily always to get the absolute longest shelf life, because the shelf life that's necessary to get the mangoes to market is determined by the system in which they're being handled. So you probably are all very much aware that there's great variation in the distance to market, from as close as northern Mexico to as far away as Brazil and other South American countries. And so what you have to do to maintain the quality is quite a bit different. And then you're meeting certain consumer demands, and the ripeness of the fruit that is being offered to the consumer is a big factor in that. And then it's the availability of everything that goes into getting the mangoes to market. That also has to come into play in deciding what you're going to do. So in general, if you need to extend shelf life of mangoes in any way, you first need to control the ripening, because mangoes are a fruit that are still ripening after harvest. Control water loss, control diseases, and you want to avoid damage and disorders with the fruit. So I'm going to start off with, I'm going to go into a little bit of mango post-harvest physiology. So this relates to the fact that mangoes ripen after harvest. Not all fruit do that. Mangoes are in a class of fruit that includes bananas, avocados, tomatoes, many melons, um, uh, papayas that are able to ripen after they've been harvested. So that opens a strategy that's very common for these types of fruit is that they can be harvested when they're fully mature in a physiological sense. They've completed the growing process and they're then able to ripen either if they remain on the tree or if they are harvested and are off the tree. And you know, uh, this is used with bananas very commonly. All the bananas that are shipped to the U.S. are harvested green. They're green, completely unripe at the time they arrive here. They go into ripening rooms, they get treated with ethylene to stimulate the ripening, and they all ripen simultaneously. Uh, Similarly, that strategy is used with apples, which have a very long potential storage life. And apples are harvested before they begin to ripen. And either in low temperature storage or in controlled atmosphere storage, which I'll talk about later, they can be stored for many, many months in controlled atmosphere, even up to a year, um, and still be very good quality. So the apples that you eat in the summer from the US were harvested the previous fall. The other class, just to fill the knowledge gap, is non-climacteric fruit. So citrus fruit are non-climacteric. Grapes, pineapples, strawberries. These are fruit that have to complete their ripening on the plant. So that whole strategy of picking them before they ripen and then managing the ripening post-harvest can't be applied to those fruit. So with mangoes, we can do that to a certain extent. So this is what the climacteric behavior is. The point at which the fruit is fully mature but not begun ripening yet is right here at what's called the climacteric minimum. And then as the respiration rate shown by the CO2 production increases, the fruit ripen. And at the same time, there's an increase in ethylene production. I mentioned that ethylene is used to ripen bananas. It's naturally produced by climacteric fruit, but if you apply it to these fruit, it'll stimulate them to ripen and make the fruit all ripen simultaneously, so you get very uniform ripening. So, climacteric fruit, once fully mature, can ripen whether they're on or off the tree. But when you're talking mangoes, the best quality is obtained when the mango harvest is delayed until the ripening has at least initiated. So, mangoes that have started ripening on the tree are much better quality than if they're harvested at that mature green stage before they begin to ripen. You get the longest shelf life, though, the longest storage life if they're harvested mature green, but the quality is not as good as if you allow them to start ripening. And of course, the drawback is as they start ripening on the tree, the potential storage life gets less and less as they ripen. They can't be kept as long. So mangoes also, they respond to ethylene. They're not a big ethylene producer. They're one of the lowest ethylene producers of climacteric fruit, but they're very sensitive to ethylene. So you need to avoid exposure to ethylene when you don't want them to ripen. But when you do want mangoes to ripen, they can be exposed to ethylene in banana ripening rooms and ripen very nicely and very uniformly, as I said. So the issues with early harvesting, which is what is done a lot commercially when the shipping time, like from South America to the U.S., the shipping duration can be several weeks, 3 or even 4 weeks. The tendency is to harvest the fruit earlier because that gives you longer shelf life, but it compromises the quality of the fruit. They when they're green, you don't really know it's not very easy to tell when they're fully mature, when they've stopped developing and are on the verge of shifting over into the ripening process. So there's more variability with the green fruit. They may not have accumulated the full amount of starch that's eventually going to be converted to sugar when they ripen. So they don't, it also is being going to be used to produce the flavor compounds, the aroma compounds that are part of the ripening. More importantly, and somewhat unique to mangoes, is they're sensitive to temperatures that are both high and low. So the mangoes that are being exported to the US are by and large getting a hot water treatment, and the less mature fruit are more susceptible to injury from that hot water treatment. On the other hand, they're chilling sensitive. So these mature green mangoes really should never be exposed to temperatures below 12 degrees. And as they ripen, though, they become less and less sensitive to both of these injuries. So fully mature fruit and fruit that have begun to ripen don't get damaged by the hot water treatment, and they can be handled at lower and lower temperatures. So you start at 12 for the green fruit. It can go down as low as 7 for about half ripe fruit and no chilling injury. So that helps extend the shelf life of the riper fruit. But what happens too often is the green fruit that are being shipped long distances also get shipped at lower temperatures, which means that they're almost sure to get chilling injury. So when we're talking about extending shelf life, we're talking about practices that help to maintain the maximum quality. And the mangoes are being harvested in pretty well-defined finite marketing systems. By finite, I mean the duration of the marketing is pretty much set by the origin and the destination. So it can be fairly short, it can be less than a week, it can be as much as say 4 weeks. And so what you need to do to successfully get through that system depends on how long that's going to be. So, but with the short time frames, then shelf life extension is not that big an issue because the mangoes, just if they're handled with proper temperature control, they're going to be fine. But as you go longer and longer, you have to take extra steps. So the goal is always to maintain the highest possible quality within the system. So what I mean by extended shelf life is that the mangoes possess the potential to maintain their highest quality throughout whatever the actual marketing period is compared to mangoes with a shorter shelf life. And so what that means is a product with a longer potential shelf life is always going to be higher quality, and that's illustrated here. So if we have the same mangoes and you rate their quality in this case like from 1 to 10, then at the beginning their quality is very good. There's no issues, nothing wrong with them. And under one condition, the quality declines more rapidly than the other. And sometimes people will say, I don't need to extend the shelf life or have longer shelf life because I have a short distribution system. But in fact, you can actually have better quality just by doing things that increase the potential shelf life. Because what this is showing is that at every point along the time period, as the days go by, the fruit that are getting the treatment that slows the quality deterioration are always going to be higher quality. So even if you don't take them out to the maximum extent of their shelf life, they're going to be better quality at any point. So to do that, to extend the shelf life, we want to harvest at the optimal maturity. So that's the optimal maturity for whatever the marketing system is. Avoid any injuries during harvesting and handling because whenever you injure the fruit, even if it doesn't cause a visible break in the skin, just rough handling will shorten the shelf life of the fruit because it increases the rate of metabolism. So they start respiring at a higher rate and using up their carbohydrate reserves faster and things like that. You want to maintain the cold chain. So you want them in the range of temperature that's not going to cause chilling injury or heat injury, but maintain that temperature, especially not allowing them to warm up at any point because there's really no way to cool them back down again to the proper temperature once they're in the distribution system. And you need to practice good sanitation to ensure food safety and to avoid fruit decay. So this is basically, this table is just showing you in general, this is basically how fruits and vegetables respond to temperature. So the mangoes are not getting the same extension of shelf life that a temperate fruit like an apple is going to get because they can be taken right down to 0 degrees. The mangoes are going to be in a higher temperature range because you have to avoid the chilling injury, but there's a 2 to 3 fold change in their potential shelf life for every 10-degree change in temperature. So that's why you need to get them as low as you possibly can within the safe range and keep them there because that's going to give you the extension of the shelf life to the greatest possible uh, amount. So that's why temperature management is the first step. That it always starts with temperature management if you're going to try and extend shelf life post-harvest. So to do that, you start with rapid cooling. So the longer it takes the fruit to reach the goal, the temperature, the target temperature, the greater the effect you're going to see in terms of compromising shelf life. You cool them down as fast as possible, get them down to the lowest safe temperature as quickly as possible. You'll get the maximum extension of shelf life. For mangoes, that means forced air cooling. That's the best cooling method for mangoes compared to just putting the fruit in a cold room and doing what we call room cooling. Forced air cooling will lower that time to reach the temperature target um, from maybe a day or two to maybe 2 hours. So it's a great difference. Um, so you want to get them into that process of cooling fairly quickly after harvest. So I'm just going to go through now chilling injury and heat injury symptoms, what effects these have on the fruit. And the first thing that happens with chilling injury is loss of aroma synthesis. So it's actually possible to have a very mild case of chilling injury where you don't see any visible damage to the fruit, no effect on how they ripen, but they lose their capacity to produce aroma volatiles. So you have mangoes that will ripen and look fine but have no aroma. And actually, I think consumers sort of have that experience in the market in some cases where the mangoes never really develop full aroma, and so that the flavor is not what they expect. The next thing you see is lenticel discoloration. This is the earliest visual symptom, but it's not specific to chilling injury. Lenticel discoloration is sort of of it's a symptom of any kind of stress to the fruit. All sorts of different stresses applied to mangoes, even on the tree, will will cause them to develop lenticel discoloration. Then you get skin discoloration and internal vascular discoloration with worse and worse chilling injury. And eventually you can get like a scald-like appearance on the surface of the fruit where it looks like they've been burned on the surface. And in some cases, you get internal browning. It doesn't always happen. This is Corte Negro that we also had quite an extensive project funded by the Mango Board to look at Corte Negro, and we know it's a chilling injury symptom, but unfortunately, we were never able um, to nail down exactly what causes it to occur in some cases, but not always occur. But you know that you've had fairly severe chilling injury when you see it. Now, with heat injury, the first thing that happens is again, you get lenticule discoloration because of the stress of the high temperature. The next thing is this cavitation that you see typically near the stem of the fruit. And you can see from the outside that the fruit will collapse in that stem area. And if you cut open, you'll see that it formed those air cavities or the cavitation. Then you get vascular discoloration. And again, you get this surface scald. So this, like I said before, this is something that you can see from the hot water insect quarantine treatment that's mandated for killing fruit flies, but it's mainly something that's going to happen to the least mature fruit in a lot. So that's why one of the strategies that people will follow is they will take those hot water treated fruit and hold them overnight because it allows the fruit that are going to develop the cavitation or other symptoms to develop those symptoms, and then they can be sorted out on the packing line. It also was found at some point that if you follow the hot water treatment with a hydro cooling treatment, putting them into cold water to get the fruit cooled down faster, it reduces the injury. But unfortunately, it also reduces the effectiveness of the hot water on insects, so the that caused new mandates to the aphis treatment. So this is how forced air cooling works with fruit in general, with mangoes, is you have a fan that is in a false wall so that it will pull air from the refrigeration, the cold room, and bring it through the fruit. And then it goes through in that false space behind the wall and it gets returned with a fan that blows the air back into the room. So what this is doing is in contrast to the room cooling, you're forcing the air to move through the cartons as these arrows show. And so that brings the cold air in direct contact with the fruit. And like I said, it speeds up the cooling greatly from a day or two to only a couple of hours in a well-designed system. And you do that by covering that space between the two rows of pallets so that the tarp that you cover it with gets sucked down tight. And the only way the air can get to the middle is by going in from the two sides and through the boxes. So continuing with temperature management, you have the containers or the truck trailers that are used for handling the fruit. The most important thing to know in relation to both those is they're designed only to maintain temperature. So you can't think that you're going to cool warm fruit by loading them onto a marine container or into a refrigerated trailer for truck transport, because in fact, there isn't enough refrigeration capacity to remove the field heat, and those fruit will either cool very, very slowly, or they won't cool at all. And in the worst cases, the heat of respiration will overcome the refrigeration capacity, and the fruit will actually increase in temperature rather than decrease. So also, the two systems are very different in terms of how the air is distributed. So this is showing a marine container, and the way the air is distributed is it's sent underneath the load. There's a false floor, and the air comes from the refrigeration system into this space. And to return, it has to go up and through the boxes. So that means that those boxes or cartons, they have to have ventilation holes on the bottom so that the air can make that vertical route. The trucks have just the opposite system. The air comes out from the top at the refrigeration unit and it goes back along the top of the load and it comes back and through the boxes from the trailer door end. So the boxes have to, in that case, have ventilation holes on the sides so that the air can move vertically. Now, if the mangoes are going to be shipped at one point in marine containers and at another point they're going to be in trucks, then you have to have the ventilation holes both top and bottom and side to side. Now, reducing physical damage, as I said earlier, this is important not only because if there's visible damage, the fruit are going to be unacceptable and graded out, or you can get a load rejected at the receiver if there's bruising and cuts and things like that. But even just rough handling that jostles the fruit and disturbs them is enough to shorten their shelf life. So the mangoes have to be handled carefully from the point they're harvested all the way through the packing line, designing the packing line so that there aren't long uh, uh, drops or sharp turns where the fruits slam into a wall before making a 90-degree turn, anything like that. And then next, you need the shipping containers to be designed to protect the fruit. They have to be strong enough that they can be stacked as tall as a pallet with no chance that the bottommost cartons are going to collapse because of that weight. And they have to be stacked in such a way that the load is not going to shift. All the boxes have to fit on the pallet. You can't have a box size that causes them, when they're stacked on a pallet, for any of them to extend over the edge of the pallet, because the carton will fail at that point and the whole stack can tip over. So this is a carton that was designed through activities sponsored by the Mango Board that is being adopted to some extent by the industry. It fits on a standard 40 by 48-inch pallet, which is approximately 100 by 120 centimeters, and fits exactly on the pallet. And it's vented both side to side and top to bottom so that it's designed for temperature management as well. So that's an example of a well-designed carton for mangoes. And you can see here that they use the braces and the straps. This is primarily so that if the pallet shifts a little bit, it's not going to collapse and fall over. It's going to retain that straight up and down matching of all the corners of the boxes, because that's where their strength is in the corners. Of course, we need to control water loss. Humidification systems can be very helpful in that regard. But in fact, the main line of defense against water loss with mangoes is the coatings that are used. Carnauba wax is a very common coating used with mangoes. It's an impediment to water movement from inside the fruit to outside the fruit, so it gives great water loss control. I want to mention here, this is just an aside, there are some newer coatings made for mangoes specifically that not only provide that water loss control, but they also control the gas exchange of the oxygen and CO2 that's being exchanged in and out of the fruit due to respiration. And that causes a modified atmosphere effect. And I'll explain modified atmosphere and controlled atmosphere later, but you can remember that there are some coatings available now that actually will have that effect. The next thing to consider is ethylene control. I mentioned that mangoes, as a climacteric fruit, they produce ethylene. They also are very sensitive to ethylene. So protecting mangoes from ethylene is probably the second most important thing after temperature control that you need to do in order to control their ripening. So especially if you have ripening initiated, or what's sometimes called tree ripe fruit, you want to keep them from ripening too fast while they're going through the distribution system. So it can be very useful to use ethylene scrubbers. Ventilation helps, but in a marine container, there's very limited air exchange. In a truck trailer, limited air exchange. So you want to control the buildup of ethylene so that you're not promoting the ripening. Potassium permanganate is a chemical that oxidizes ethylene. It takes the C2H4 of ethylene and changes it to CO2, carbon dioxide. And there's a lot of brands that do that. Activated brominated charcoal is something that's used more commonly in storage conditions, but it's another way to absorb and remove ethylene. I've been doing a lot of work over some years with a palladium-based ethylene absorber. It actually physically absorbs the ethylene. It's not a chemical action like potassium permanganate. It's marketed by It's Fresh as Ripen, and its main benefit is it has a much higher capacity for absorbing ethylene than the potassium permanganate pellets do for converting ethylene to CO2. So with a little, you get a lot more effect. And this is basically just to keep the ethylene below a level that will stimulate faster ripening. Other methods of ethylene control that are available but not all that commonly used include ozone or UV radiation to oxidize ethylene. And the ozone is O3. It's a very active oxidizer. So, like the potassium permanganate, it oxidizes the ethylene to CO2. UV has the same effect because UV changes the atmospheric oxygen, the O2, into O3, and then the ozone that's created then has the same ozone effect. Um, there's also catalytic converter type units that will oxidize ethylene as well. But these are units with a small fan where you have to circulate all the air in a container or in a storage room through that small unit to get the effect. And we found that the efficiency of that is not great. There's also an issue. We found this also with ozone. It's such a strong oxidizer that it reacts with almost anything. It reacts with wood and paper and rubber and glues. So we actually did some work at one time with one of the refrigerated transport companies that was trying to introduce an ozone generator for containers and trailers. And they eventually gave up on the project because they found that it shortened the life of the trailers and containers by oxidizing the glues and the rubber that were part of the components of the trailers. But it has trouble making a full circuit because it reacts with everything so quickly that almost no ozone would ever get back all the way back to the origin of the unit. So that was an issue. The other big way for controlling ethylene that has got a lot of attention in recent years, it's being used for fully 50% of the apple crop, for example, another climacteric fruit where they're controlling the ripening. What 1-MCP does, it's a gaseous compound that mimics the structure of ethylene, the double bond between two carbon molecules, so that 1-MCP will attach to the ethylene binding site that's within the cells of the fruit. But different from ethylene itself, when 1-MCP binds, it never releases. So every time a 1-MCP molecule attaches to an ethylene binding site, that binding site is permanently out of commission. So you apply enough 1-MCP to block all of the ethylene binding sites, the fruit becomes impervious to ethylene. It acts like it cannot perceive ethylene anymore. So that's great. And they use that, like I said, during the apple storage, and they actually reapply it periodically during the months and months of storage, because the way the fruit can overcome the 1-MCP is by synthesizing new binding sites when there's no longer any 1-MCP around. And eventually they recover. So with the apples, they have to reapply. But with a fruit like mango that doesn't have nearly the potential storage life, the issue is actually getting the fruit to ripen again when you want them to ripen, because you don't want to completely stop them from ripening, because then they don't ripen when you want to sell them and people want to eat them. So we did some work with the a product from a company called Hazel Technology that just telling you because we did this research, they came up with a sachet that releases 1-MCP in the carton, in the shipping box. So you put a sachet into the box with the fruit, they release some water, or it's in a humid environment, you get 1 MCP released, but they designed it so it's a very, very low rate of release so that you never completely stop the ripening, you only slow it. So we found that what this means is that it's sort of like an add-on to low temperature. You slow the ripening, but you don't completely stop it. So that actually is somewhat effective. And that's really the only way I would recommend using 1 MCP for mangoes is in a system like this where you're not applying a saturating dose and completely knocking out the ripening altogether. Now, to controlled atmosphere, and modified atmosphere packaging. In the introduction, Wanda mentioned that's the most recent project that I was involved with, funded by the Mango Board. So we identified this issue that I mentioned early on in my talk, that the longer the distance to get to market, the more likely it is for exporters to use less mature fruit and put them at lower temperatures, which is really not doing the mango any favor in terms of the eventual quality that you're going to get later on in the market. So what we looked at was, is it possible to use CA, MAP to ship tree ripe mangoes from South America to the US? And we used 4 weeks as our goal for how long the fruit needed to be kept in good condition. Controlled atmosphere research with mangoes is something that I've been involved with a very long time. I had a student who got his PhD in 1996 who worked with controlled atmosphere with mangoes, a fellow from Brazil, actually, Renard Bender, who's a professor about to retire down there, if you can believe that. And so we knew that the CA would work. And there's such a thing as controlled atmosphere marine containers. And so that is available and definitely would work for mangoes. The issue is that there's a upcharge of about $1,200 to $1,500 per container for the CA service. Plus, there's not an unlimited number of these containers available. So, from a practical standpoint, there's not enough of them to handle the volume of mangoes. So, what we did was we looked at modified atmosphere packaging. Um, and so, knowing what CA would be effective with tree ripe mangoes, we worked with a company called Breatheway that made for us modified atmosphere packages based on measurements we did of the respiration rate of the fruit under the controlled atmosphere. And then we tested those in the lab and also with eventually with shipping tests from Brazil and Peru, from Brazil to New Jersey and from Peru to California. Also, because we had done previous map work where we found that the package, yes, it's permeable to oxygen and CO2. That's how it creates a modified atmosphere. It's not very permeable to ethylene. So ironically, the map that you're using to lower the oxygen and increase the CO2 to slow ripening is actually allowing ethylene to build up inside the package, overcoming the modified atmosphere effect. So we also looked at these ethylene scrubbers from It's Fresh that I mentioned before that we had done work with to see if the map by itself was effective or if it was necessary to also absorb the ethylene being produced. So we did that research and it's finished. I've actually reported on it at 2 meetings in November in New Zealand and just last month in Washington at a CA conference in Wenatchee, which is the heart of the Apple CA storage area in the United States. And so our eventual conclusion was yes, you can even ship mangoes up to 5 weeks. And that would include the time in the port at either end, the delays and the long shipping time. You could go as long as 5 weeks in a modified atmosphere package that creates a similar atmosphere to the CA. And so for tree ripe fruit, which on the 1 to 5 scale that we're familiar with, or 0 to 4 if you use it that way, on that scale, fruit of 3 to 4, which is quite advanced, could actually be stored that long if you get 4 to 6% oxygen and 5 to 10% CO2 at 7 to 8 degrees. So as you can see, we're able to put them at a much lower temperature than the 12 degrees. That's a safe temperature for green mangoes, and we're able to get that kind of shipping test. Now, where the coating came in is on the side. We also worked with that acorn coating company, and they worked with us. We went back and forth, and they were also able to develop a coating that contains zein, which is a protein from corn, to make it semi-permeable like the modified atmosphere package film, and created the same internal atmosphere of oxygen and CO2 inside the fruit as you get with a controlled atmosphere or modified atmosphere around the outside of the fruit. So that also was successful, and that's another potential option that we weren't aware was even potentially possible going into the MAP project. But actually, Leo Ortega from the Mango Board put me in contact with the acorn people, and so we started doing that on the side. Okay, getting towards the end here, decay control. I'm not a pathologist. This isn't really my area, but I know that anthracnose and stem end rot are the two most important, most common post-harvest diseases that affect mangoes. And with both of these, I think the bottom line, and when I was in China recently, I was talking to a pathologist there, and he agreed that control in the orchard is the way to go, that trying to take care of these post-harvest is not very effective. You have to reduce the population, the pathogen load in the field in order to reduce these decays. In the US, there's no post-harvest fungicides labeled for mango, so there's nothing you could apply to the mango after harvest anyway. Something interesting, though, is that the hot water treatment used for insect quarantine actually reduces the decay. We had a pathologist here at University of Florida who looked at this for us early on when we were doing some hot water treatment studies with mangoes. And what he found is that the quarantine hot water treatment does not kill anthracnose. He was looking specifically at anthracnose, Colototricum, but it weakens it to the extent that when the fruit come out and go through the post-harvest period, the pathogen is much less virulent. It's weakened so that it's not as strong a pathogen anymore. So it doesn't as strongly cause the decay lesions to occur. Also, he found that 100 parts per million sodium hypochlorite, which is very commonly used in any place post-harvest where there's water touching the fruit or vegetables, they use sodium hypochlorite. That also helps control the disease. I had a visiting PhD student from Pakistan a few years ago looking at a coating using chitin and adding thyme oil, an essential oil that has fungistatic properties. And he found that it was as effective at controlling anthracnose as Prochloraz or Sportac, which is a post-harvest fungicide labeled in other countries, even if not the US. So actually, that's an avenue also that could be pursued, is coatings that contain natural fungistatic compounds like chitin and aloe and thyme oil as a way to control decay. Okay, and with that, I've finished everything I know about extending the storage life of mangoes, and I'm open for any questions now in the time we have left. Thank you.
Thank you, Dr. Brecht. And let me open the chat here to see what questions we have. We have from, let's see, Jesus Macias. He says, what would you recommend in terms of temperature, mango handling for air freight, considering temperature changes between cooling storage at airports, tarmac temperatures, and in flight temperatures?
Yeah, I didn't mention air transport specifically because I'm not very high on it, and it's because as you already are aware, there's a lot of places for breaking the cold chain during air transport. It's very uncommon for there to be any kind of temperature control. There is such a thing as containers for air transport that have mechanical refrigeration, but there's a big issue with what happens to them once they reach their destination. There's nothing to put them in to send them back, so that makes it economically questionable. And the handling, unless you're going through a airport that has a dedicated perishables air freight facility that will hold the product at low temperature while it's waiting to be loaded. It's loaded on the plane with insulation. The trip is fast. So the only thing I can say is that you can't take the mangoes down below their chilling threshold temperature because, like I said, even a short exposure uh, can compromise the flavor quality. You just have to get them to their proper temperature, use insulation during the flight to try and minimize the rewarming, and then at the other end, they go quickly to market. There are a few logistics companies at airports, like I'm aware of this at Miami. There's one that I visited called HPL, where they actually have the ability to do forced air cooling of the product on arrival. So they cool it back down again on arrival before it goes on trucks to continue on its way. That's the best you can do.
Thank you, Dr. Breck. We have a comment and a question from Mauro Ferreira. And he writes, thank you for the presentation, very informative. And he goes to say, since high or low temperatures can directly affect shelf life and quality, in your opinion, why is irradiation for phytosanitary treatment not used more widely? Could it be related to the cost or availability of this type of treatment?
Yeah. So it's been shown with research that irradiation can be effective in inhibiting the ripening of mangoes specifically. There's technical, practical issues related to irradiation. One is that when you apply irradiation, it's being absorbed by the tissue. So as it moves through a load, a mass of mangoes, the radiation dose is declining, declining, declining. So to apply it effectively, it really needs to be applied on a single fruit basis, like with fruit on a conveyor belt, which is usually not what's done. If you try and apply a radiation to a pallet of mangoes, they'll do something like put it on a turntable so it's turning around and all sides being exposed to the irradiation source, but the center of the palate is going to receive a much, much lower dose than the outer part of the palate. And so, just like anything else, there's a balance between having enough irradiation and too much irradiation that can cause injury. So you have the potential of injuring the outermost fruit while not getting a high enough dose in the middle. So that's the practical issue with irradiation. And then, unfortunately, um, at the retail end, they're very concerned that there's consumers who just, I don't know, pardon me, they stupidly equate irradiation with radiation like nuclear weapons, and so they're afraid of it, and they're going to march outside their store or something like that. So they just don't want to handle irradiated fruit. So, that's the other issue. That's why irradiation is not being used more widely. It could be effective if it was applied, like I said, on a conveyor belt type system. I'm not sure that it's worth the expense and the effort, but it does work.
We have one more question from Pascal Denencourt, and the question is, can the acorn coating be used as a standalone treatment? How many more days does the mango get with this treatment?
Yeah. So what we did when we were doing the work with those coatings, and when we got to the final coating that did what we wanted it to do in terms of creating the internal modified atmosphere, we did an identical experiment as we had been doing with the modified atmosphere packaging, which, as I told you, resulted in showing that you can keep basically half ripe fruit, like stage 3, even up towards stage 4 fruit, for 4 weeks. You could do the same thing with the coating. So it's the equivalent of a modified atmosphere package, with the coating taking the place of the plastic film package to create the modified atmosphere.
Once again, thank you, Dr. Brett, for this insightful presentation. Next up, the Science of Wellness, National Mango Board and Nutrition Driven Consumer Strategy. In this upcoming webinar, we will explore the NMB's health and nutrition strategy, how findings from our research are shaping our new wellness positioning, and how this will inspire consumers to enjoy fresh mangoes. The presenters will be Alison Beadle and Carrie Laskin, and that will be on July 24th, 2025. And with that, we conclude today's webinar. Thank you for joining us.